this one, linear. Linear momentum, okay? Linear momentum, we shall say that is a product of mass of a body and its velocity. Is the product of mass of the body and its velocity, in a straight what? In moving in a straight line. Moving in a straight what? Straight line. I.e. momentum equals mass times velocity. Okay? And then we shall now say the SI what? SI units. We have kilogram for mass, meters per second for velocity. Okay? And then we shall say that now from Newton's second law of motion, m into v minus u over t, ft is equal to m v minus mu, where mv minus mu is change in momentum. Change in what? In momentum. So since it's change in momentum, then I will say that the quantity ft is called impulse. The quantity ft is called impulse. The quantity ft is called what? Impulse. Then we shall define, say, impulse is defined as the product of force and time for which the force acts on a body. Then we shall go SI unit of impulse. SI unit is Newton second. Newton what? Newton second. That is the SI unit of what? Of impulse. Okay? So we shall now say that well, from F is equal to M over T into V minus U. M over T is called rate of mass. Rate of what? Of mass. We shall call M over T rate of what? Of mass. So the force, we shall now say therefore, force F is equal to rate of mass or mass per second times change in velocity, not so? Mass per second times velocity what? Times velocity change. Velocity change. Examples. Let us look at examples that require that, okay? Examples that require that. So we have this, let's say examples, a body of mass 5 kilograms, initially moving with a constant velocity of 20, and experiences a force of that in that. So 5 impulse. So part 1, solution. Part 1 we shall say impulse I is force times time. Which force is what? Is 20. The force is what? The force of 10 times 2, giving us 20 Newton second. Part 2. The velocity when the force stops acting. So that means that we know very well that impulse, okay, when the force stops what? Acting. So how do you get the velocity now? Because we know that impulse is equal to mv minus mu. Okay? So what the final velocity? So impulse is 20 will become mv mass, which mass is what? It's 5 times v minus 5 times what? U. Initially it was moving with the velocity of what? 20. Okay? So this is 20 plus this is 100 is equal to 5 what? V. Okay? So meaning that this becomes what now? 120 is equal to 5 what? V. So our V will become 120 divided by what? By 5. So it gives us what? 120 divided by 5. What do you get? 120 divided by 5. I think I'll use a calculator. That's 25, I think. That's 24 meters per second. Is that okay? Then we go to number what? Number 2. Okay? We go to number what? Number 2. Number 2 says, number 2 says the body, they have given us the mass of the body, velocity they have given us, so we shall say impulse I is force times time, so the force is 15 times 2 giving us 30 Newton per second. Next, they are saying that find the final velocity. Part 2, we know very well that impulse is changing velocity, changing momentum. Not so? So our 30 will become, the mass is 2 times V minus 2 times U, U as 2. So you add here 30 plus 4 should give us 2V. So our V will become 34 divided by 2, which gives us 17 meters per second. Like that. Then we can go ahead and look at the exercise. So we are having the exercise. Okay, that's exercise. Here we have these two numbers that you do as exercise. Now for this one, they are asking us the force. This is the water which is striking the wall, and I saying that supposing the velocity after the striking is 0, meaning that there is no rebounding. If there is no rebounding, then the velocity becomes, the final velocity is 0. But if there is rebounding, that means that the change in momentum will be, if this is, for example, this is the wall and this is the wheel. So after that, it goes with speed u, then it rebounds with another speed u. So meaning that initial momentum, in that case, is m what? Mu. Then the final momentum will be equal to negative of m what? Mu. So the change, this minus n. So the change in momentum will become what? This minus this, which becomes 2 mu. So that's a change in momentum, meaning that the force will become what now? The force change in momentum, that is 2 mu divided by what? By time. If there is rebounding, if there is no rebounding, then the final velocity is 0. Okay, the final velocity is what? Is 0 if there is no rebounding. Sometimes it can rebound in another direction. It bounds like this at a certain angle. Now, if it bounds at a certain angle, then you have to get the component, horizontal component of that what? Of this velocity. Which horizontal component will become u cos of that angle. Of course, you know how to resolve. Okay? So those are the three numbers. So you don't have the mass, but having been given, you know the next step, you know they have given the area, they have given you the speed. So from speed and the area, you can get the volume. You can get the volume, okay? Because if this is the pipe, okay? So they have given us this area. They have given us the speed. We know that area, okay, volume equals length times width times height, okay? So divide by time, divide by what? By time. By what? By time. So you can see the volume over time per second will become, this is the area times what? Times speed, times velocity, okay? So from there, we can get volume per second. After getting volume per second, okay, we can go ahead and get the mass per second. Per second will become density times volume per second. Okay. So here we get mass per second. After getting mass per second, you know that our F is equal to m over t into v minus what? So you can get this force because you already have this mass per second. Is that clear? The density of water is 1,000. You know that one very well. So let us go and look at the law. Okay, NB. NB. We say from NB, from F equals m into v minus u over time, implies that when time of impact is small, the force applied, the force exerted is high, since the rate of change of momentum increases. The rate of change of momentum increases. Momentum does what? Increases. And vice versa. And vice versa. Then we shall say, this explains the following. So when the time of impact, the time for which the bodies are intact, is small, the force exerted will be very high. Because this will be, the rate of change of momentum will be very high. So this explains the following one. The long jumper lands on sand. The long jumper lands on sand in order to increase the time for which the body is being brought to rest. This reduces the rate of change of momentum, Hence, the force the ground exerts on the legs reduces, thus less pain. That's one. Number two, the water drop from the iron sheet digs the ground. Water drops from the iron sheet, dig the ground. Of course, you know why it means the time of impact is very small. This increases the rate of change of momentum. Hence, the force exerted on the ground is very high. Next, the long jumpers flex knees. The long jumpers flex knees, flexing knees to increase the time for which the body is being brought to rest, hence reducing the rate of change of momentum. Thus, the force reduces exerted on the legs, hence less pain. Number four, martial arts prayers. They call them martial arts prayers. Martial arts prayers can break the knees, can break the bricks with ease. So where you get bricks, pile them together, and then you hit and break them. Okay? Why? The hand moves so fast in order to reduce the time of impact, which increases the rate of change of momentum. Hence, the force applied is high, thus breaking the bricks with ease. That is done. We proceed, we go to conservation of momentum. We move on and go to conservation of momentum, okay? The law of conservation of linear momentum. We say it states that for a system of colliding bodies, their total momentum remain constant. Their total momentum remain constant in a given direction, provided no external forces act. Okay? We say consider two bodies A and B of masses M1 and M2. So this is A, this is B, this is velocity U1, this is velocity U2. So after collision, they separate. This one moves with velocity V1, this is A, this one moves with velocity V2, this is B. So this is before collision, this is after collision. So we shall say that the momentum, so here to have before collision, the momentum before, total momentum before collision, okay? Total momentum before is equal to, before collision is equal to total momentum after collision. So we shall say for A it is momentum is mass times velocity, so it is M1 U1 plus M2 U2 is equal to, this one is M1 V1 plus for this one is M2 V2. So what does it mean? It means that M1 U1 plus M2 U2 is equal to constant, is equal to constant, is conserved. Okay? It's equal to constant. There is a proof. Let us do that. We say consider two bodies. consider a body to, let's write it. Consider two bodies, A and B, of masses M1 and M2 respectively, initially moving with speeds U1 and U2. Full stop. Then we say, let V1 and V2 be their final velocities after collision. So we shall have this. Let's have the same diagram. We have the same diagram here. So we shall now say that from Newton is the second law. Force exerted on B by what? By A. Let us call it F1. Force exerted on B by A, we call it F1. But we know that force is equal to the rate of change of what? Momentum. Mass times change in the velocity over time. So it will be, now, if the A exerts force on B, the force exerted on B, who exerts the force on B is A. A exerts the force on B. Who moves? Is it A to move or B to move? It is the B to move. So the change in momentum is for B, not for A. The A exerts the force on B. So the B moves, okay? So it will be mass of B, that is 2. This is V2, change in velocity, V2 minus V1 minus U2 divided by time of impact. Force exerted on A by B. That's F of. So we can let us call this one F A, we call this one F of B. F exerted by B on A. So we shall use the parameters of A. We shall use the parameters of what? Of A. So that will be mass of A, M1, V1 minus U1 over change in what? Time. Then you say, from Newton's third law of motion, from third law, what does it say? Third law says, to every action, there is equal but opposite what? Reaction. Put a negative there. Okay? So we shall now say that this one is M2 V2 minus U2 divided by change in time will become negative M1 V1 minus U1 divided by change in time, like that. So this will cancel, open brackets, M2 V2 minus M2 U2 will become negative M1 V1 plus M1 U1. So for it terms, negative M2 U2 is minus now M minus M1 U1 is equal to negative M1 V1 minus. So take this on the other side, minus M2 V2. Divide both sides by negative 1. So this becomes, we start with this one, M1 U1 plus M2 U2. We are dividing both sides by negative what? Negative 1 will be equal to M1 V1 plus M2 V2. Hence M1 U1 plus M2 U2 should be equal to constant. Is conserved. Is what? Conserved. Then from there, that's the proof. Then let us go and look at it. Collisions. Okay? Collisions. We look at collisions. We shall say in an isolated system, momentum is always conserved, but kinetic energy may not be conserved. Types of collisions. Types of what? types of collisions. Number one, elastic. Number one, elastic collision. We shall say under elastic, we shall say it is also called perfect elastic collision. It is also called perfectly elastic collision. You know, say this is a type of collision in which momentum and kinetic energy are conserved. E.g., collision between gas molecules or air molecules and electrons. Gas molecules, the collision between electrons, the collision between the balls they separate. Number two, inelastic collision. Inelastic collision is a type of collision in which momentum is conserved but kinetic energy is not conserved. Then we say, in this collision, the bodies separate and move with different velocities. The number three, perfectly inelastic collision. This is a type of collision in which bodies stick together and move with a common velocity. The bodies stick together, move with a common velocity, and kinetic energy is not conserved. E.g., the collision between a bullet and a wood. Sperm and ova. Then we continue. We go to examples. We go to mathematical treatment of what? We say, we can say, consider an object. So they are telling us that consider an object of mass m, initially moving with speed u1, makes a head-on collision. Head-on elastic. Elastic means the bodies, the kinetic energy is conserved and they move with the different velocities. So the first thing is we are going to conserve momentum. Isn't it? Conserve momentum. The first thing is conserve momentum. Okay? So we shall say that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But when we look at what we have here, we are eliminating masses, okay? So we can put the similar masses to one side, correct terms. So m1 u1 minus m1 v1. Okay? So we are putting masses together is equal to what we have here, that is m2 v2 minus m2 v what? u2. So our m1, okay, into u1 minus v1 is equal to m2 into v2 minus u2. Want to eliminate masses, okay? Then part 2, conserve kinetic energy. The next step, conserve what? The next step is to do what? Conserve kinetic energy. Those are the steps, as long as it is elastic collision. So we shall now say I have m1 u1 squared plus I have m2 u2 squared is equal to I have m1 v1 squared plus I have m2 v2 squared So a half is cancelling, and we put also the masses on one side. So m1 into u1 squared minus v1 squared is equal to m2 into, that's the v2 squared minus v1 squared. That's equation 2. This equation 1, this equation 2. So how do we eliminate masses? Equation 1 divided by equation 2. So this will be u1 squared minus v1 squared divided by this one here, u1 minus v1 is equal to, this is v2 squared minus v1 squared divided by v2 minus v1 here, and v2 minus u2 minus u2. This is u2, and even here it was u what? u2. This one on the other side. So from here, this is the difference of two squares. Okay. So this is u1 minus v1 into u1 plus v1 divided by u1 minus v1. Okay, is equal to v2 minus u2 into v2 plus what? u2 divided by v2 minus u2. So this will cancel that, this with that. We are left with u1 plus v1 is equal to v2 plus what? u2. So it means this one comes here, that's v1 minus v2. Okay, is it the one? Oh, we can take this on the other side, right? So that we have this one, the other side we have u1 minus u2 is equal to v2 minus v what? v1, which is the same, which is the one we have asked you to show. Okay, like that. So we are also going to look at, I think it will be clear for you. We are also going to look at the next one. I want to look at another one to do with the collisions. A particle P of mass m1, number 2. A particle P of mass. So we are looking at this one. So here we have a particle, this is P, moving with the velocity u1, collide this head on with another particle u2 is equal to 0. This is h2. After collision, this P moves with the v1. This 2 moves with the v2. So we shall now say, one, conserve momentum. Conserve momentum. Conserve momentum first. So we shall now have m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. But then this one was stationary, so we shall have m1 u1 is equal to m1 v1 plus m2 v2. Now from here we are eliminating what? We are eliminating our v what? v2. We don't need v2 here, not so. So let us eliminate v2. We shall have m1 u1 minus m1 v1 is equal to m2 v2. So our v2 will become factorize. This is one m1 over m2 into u1 minus v1 u1. But then this is beta, so v2 will become beta into u1 minus v1. Equation 1. The next thing is conserve what? Kinetic energy. Conserve kinetic energy. So come back here. Here, this is a half m1 u1 squared is equal to a half m1 v1 squared plus a half m2 v2 squared. So let us make v2 squared the subject of formula. So our v2 will now become this is m v2 squared will become, this is m1 u1 squared minus m1 v1 squared. So v2 will become m1 over m2, this is squared, into, okay, here into u1 squared minus v1 squared. So equation what? 2. Put 1 in 2. Put 1 in what? In 2. Put equation 1 in what? In 2. So put 1 in 2. Okay? If you put 1 in 2, we shall now say put it to be b squared into, this is u1 minus v1 squared is equal to, this is this is beta, by the way, that's beta into u1 squared minus v1 squared. Now from there we can this is the difference of two squares, okay? So this will cancel with that. So we shall have beta into u1 minus v1 into u1 minus v1 is equal to, this is u1 plus v1 into u1 minus v1, difference of two squares. So this will cancel with that. We shall have beta into u1 minus v1 giving us u1 plus v1. Now open brackets, beta u1 minus beta v1 should give us, here it is u1 plus v1. Correct exams, we shall have beta u1 minus u1 is equal to v1 plus beta v1. Factorize out u1 here, we shall have beta minus 1 is equal to v1, we shall have beta plus 1, okay? So we want to divide. When you divide the two, we are u over v1, u over v1. So u1 over v1 will become, this is beta plus 1 over beta minus 1. So that is how we can simply show that. So then the other one is saying, so the other one is saying that show that, go to part 2. This video I'm recording it is late evening. Part 2, we shall start from here. From u1 over v1, from this one. From u1 over v1 is equal to beta plus 1 over beta minus 1. So they are asking us to show that v2, okay? They're asking us to show that v2. So we already have our v2, but our v2, we have it, we got it as somewhere. It was beta into u1 minus v1, something like that. Okay? So can we want to eliminate? We want to eliminate u1. We want to eliminate u1. So it means that here we can, our u1 will become from star. This is star. Our u1 becomes v1 into beta plus 1 over beta minus 1. So we substitute here. So v2 will become beta, okay, into we substitute here. Okay, let's first put open the brackets here. So v2 will become beta u1 minus beta v1. Okay. So from there we can bring this on this side, or we can substitute. So when we substitute, we shall say v2 is equal to, we are eliminating what? We are eliminating u1. So what is u1? What is u1? We substitute. So this will be b. Okay. u1 is where? Oh, this is our u1. So we're substituting it here. So when we substitute our u1, we shall be having, first of all, our u1 will become what? Our u1, I think we made a mistake here. This is our u1, okay? Then all else we can substitute from equation 1. v2 is equal to beta into u1 minus v1. v2 is equal to beta into, okay? We can open the brackets here and make u1 the subject of formula. So this is v2 will become bu1 minus v1. So this one comes here, v2 plus beta V1 should give us U1. So meaning that our U1 will become V2 plus beta V1 over beta. So putting this one there, put this one here, okay? But our U1 is what? But our U1 from star, our U1 will become B here, will become we substitute, or I can get this one substitute there. So I can say that V2 plus beta V1 over beta V1 now is equal to beta plus 1 over beta minus 1. So we can cross multiply. Cross multiply. So when you cross multiply, we shall be able to have what? So okay, cross multiply. When you cross multiply, you'll be able to get your answer. Though it is dark, you may not be seeing properly, but you'll be able to see your answer. So when we cross multiply, with here we shall now say cross multiply. We shall say beta. Here we can divide. Yes, we can divide. We can divide both sides by beta, down, up and down. So we shall have V2 over beta, okay, plus V1 over V1 should give us beta plus 1 over beta minus 1. Cross multiply. So this is beta minus 1 into V2 over beta plus V1 should give us